Good afternoon, everybody. My name is Ramakrishna, Chikkala, and Rama for short. And I would be presenting on the topic as shown there. I won't say this is a topic. It's probably the question in the minds of people who are involved with Wi-Fi 7, either on the client side or on the network side. So let's get in and see, what is there as per the experimental results that we have done. One of the things is that I wanted to keep this simple. So the test is going to be really, really simple. And the more complex tests would be done in the future. And probably I will have time to present that in some other WBA conference. Coming back, the promise of MLO in Wi-Fi 7, as seen on this, I would say the picture from the Wi-Fi Alliance, it is supposed to provide deterministic latency, increased efficiency, and greater reliability. So the key is deterministic latency. So my topic is that's why latency, but that there are other advantages of this feature that I call as MLO, multi-link operation. I hope everybody is aware of this. Is high throughput and probably greater reliability. I think the higher throughput is mainly because of the use of multiple channels. So it's pretty obvious. The latency is what is not so straightforward. So let's get in and check how this is doing. I would explain the components and test procedure used. And you may be aware that there are multiple types of multi-link operation that are allowed in Wi-Fi 7 or 802.11b. And I'm taking two of them. One is the MLMR, which is multi-link, multi-radio, the STR operation, which is simultaneous transmit-receive operation. This is probably the most deployed type of MLMR. There can also be an NSTR type, which I would not be covering. And then we have the EMLSR. The E stands for Enhanced Multi-Link Single Radio Operation. This probably would be the most used in the world because it is single radio, so it is cost effective. And it is supposed to provide good results. And let's see what happens. What do we expect in future with respect to the MLO or the feature MLO in Wi-Fi 7 is something that we can speculate if we have time. And for some questions in the end, where my colleague Arnav also will join. This is the AP and client configuration that is used. So the mode, WLAN mode, is Wi-Fi 7, which is the IEEE 802.11be. It supports 4 spatial streams. And the configuration is set to 160 megahertz in 6 gig band and also 160 megahertz in 5 gigahertz band. And the AP supports MLMR, STR, and as well as EMLSR. The AP supports MLMR, STR for 3 links. However, the client device is supporting MLMR, STR only 2 links. So 2 links is what would be effective. The client device is 2x2, that is 2 streams only, because that would be the typical deployment. And we don't have really client devices supporting 4 streams today in commercial market. And the bandwidths are also set to 160 megahertz on both 6 and 5 gigahertz bands. The traffic application that I used, I'm sorry, it just got overlapped, is iPerf2. And I would give a link to the site. The reason for choosing iPerf2 is because it provides inbuilt latency measurement for both TCP and UDP traffic in the latest version of iPerf2, which is which is the reason why we selected this over iPerf 3. Having said that, there is a necessity uh, to generate interference, or you may want to call it congestion, to do the test, because simply doing latency tests with no congestion or interference has no use. I mean, that's the typical use case would be that you are in a congested environment and MLO is supposed to deliver the latency that it has promised. So for this, we use our own interference generator. I mean, for those who are aware of this, I mean, it's the OBSS interference that we are trying to generate, and our equipment, which is called YCheck, is used to generate this interference. So the interference generated by this device can be precisely configurable in either 2.4, 5, and 6. The test is mainly done in 5 and 6. And the channel occupancy level, the amount of occupancy of the channel that is already there before we start the test, can be set to any of these levels. These are selected just for ease of use. And it can generate noise or interference across multiple bands simultaneously. So the test involves generating interference on multiple channels, and hence this choice. And this is automation ready, and we can automate the test and get our results fast. The first thing is the MLMR STR part of it, the first type of MLO that I discussed. So we have the test setup as follows, because I would like to spend a few minutes on the test setup so that we are very clear, because the results are very easy to be presented. I have to present one graph, and it will be pretty obvious. But I would like you to understand the test process, because that defines how the whole thing is going to work. So we have put the AP and the client in a chamber large enough, but not too close, so that the throughputs are more realistic, not just be at 1 foot distance. And in parallel, we also have this interference generator talking to the interferer AP, which would actually generate the OBSS interference for the test for the DUT, which is both the AP and the MLMR STR client. We also have a multi-band sniffer. For lack of time, I'm not going to really show the captures, but which can actually determine that indeed the MLO connection has gone through, and the test is the right one, and we shouldn't be going into the non-MLO territory. So we have PCs connected with the iPerf 2 application to measure the latency, and iPerf 2 anyway gives the throughput as well. So we would be getting the throughput results also. Having said that, the first result is the throughput result that I'm presenting. Before doing this test, we have done other tests, which for lack of time, I could not present. We also have done a test with interference in one link. So you know that MLO uses 2 links, and if you compete with a client that in which the MLO is disabled, if you use 2 links to 1 link, it would anyway be good. So I kind of removed all those results, and we only have the results with interference in both links. That's what we would probably face in real life. So we have this TCP throughput that has the MLO off and MLO on case. For switching off MLO, we have used a different software on the client to switch off the MLO from the internal control. As you can see, MLO performs really well as we increase the interference. And at 80% interference on both channels, MLO is doing far better than the non-MLO case. And it seems the difference seems to be slightly bigger, but overall, this is on expected lines. We have two links, so the MLO client should be actually getting better throughput. And since we are using symmetric bandwidth, 160 megahertz on 5 and 6, this shouldn't really affect anything else. One of the reasons for choosing this symmetric bandwidth is also the fact that TCP performs well when you have something like this. If there are asymmetric links, the acts don't come in a regular manner, and it would affect the MLO throughput. The next slide is about the TCP burst latency that IPERF2 measures. And as you can see, here the MLO performs really well, even at 80% interference. I understand this is a single client result. I would discuss a little bit on the multi-client results in the end, just so that we can close on the topic. But it seems with MLMR STR, the clients are really going to do far better than the clients that don't support MLO or the ones that are on a single link all the time. So in a nutshell, MLO is delivering on the promise for a single client case. The next one would be the results with EMLSR. For those of you who are aware, EMLSR is a client or a type of MLO where there is a single radio used, but the client can listen to control information on the second link. And this helps switching between the links in a very fast way, unlike any other kind of steering mechanism or sending deauth so that the client connects into the other channel and so on. So this is kind of what I would say a shortcut to get the latency without spending on the cost of having an extra radio in each of the client device. As I mentioned before, the AP itself is supporting both MLMR STR as well as EMLSR, but since the client only supports EMLSR in this test, so the other part has no relevance. Now we are doing the test in a similar way. Again, here there is a discussion whether we should be doing interference on single link or both links. The single link case is very obvious. If we have a client that supports EMLSR and can switch links, if you put interference on one of the links, it would shift to the clearer link, and you would get all the benefit. But that's not the point. The point is to have interference on both the links and actually get to the bottom of it, whether it's going to perform in real life really well. The rest of the test setup remains the same, and we do have the interference generator without which we cannot do this test, and we have the IPERF2 on the PC to run the test. So this is a result of the throughput with EMLSR, and as you can see, the throughput for the EMLSR client is slightly higher, but not to the extent that we have seen in MLMR STR. And this is pretty obvious because we still have only one link, and the improvement mainly comes from the fact that if you assume the interference to be random on both the channels, because of the enhanced version of the MLSR, there is an intelligent switching between the channels, and you should gain the throughput. So the throughput gain in the last 80% case is 18%. So it's good, but we are looking for latency. So that's in the next slide. Yeah, here it goes. So with 80% latency, the EMLSR client is still having lower latency by 15%. So it does deliver on the latency in a marginal way. What I have not shown here, as I said, for lack of time, is that if you have interference in only one link, the EMLSR performance is actually as good as the MLMR STR performance. So there is a marginal increase in latency as well with EMLSR. Let me put the comparison here in a single chart. So we have first the EMLSR. This is the EMLSR result, and we have the throughput marginally better. We have the MLMR STR result where the throughput is far higher, and the burst latency also is similarly better with EMLSR, but more pronounced in the case of MLMR STR. I would like to reiterate that EMLSR performs as good as MLMR STR with an interference on one link, which I have not presented here, but we should note on this. Okay, I do have a problem with the formatting, but the message is very clear. There is definite increase in throughput and burst latency when we do TCP tests with both MLMR STR and EMLSR clients. On the EMLSR clients, the improvement is marginal, or like 10 to 15%, whereas because of the use of two links, there is more increase in the throughput and reduced latency in the MLMR STR case. What do we expect in future? I said I will just give a brief on what would happen if we increase the multi-client results. My team back there have actually done some tests with multiple MLO clients in the last week. And it looks like the basic hypothesis holds good. We would really improve in latency. But let's say if we go back, no, sorry. Yeah. Thanks. If you go back here, the interference that we have here, 20, 40, 50, 70, 80%. Now, the latency improvement will probably get cut off at a lower interference level. I mean, as you increase the number of clients, at some point, EMLSR would perform at a similar level as a client that does not have MLO at a reduced interference level. So, which means that at 80, these two towers may be the same. Similarly, for MLMR STR case. So, the cutoff at which interference level MLO may work would change, but not the basic hypothesis that the latency would really improve. I think there would be some client preferences with respect to MLMR, STR, and EMLSR, or maybe even something called EMLMR, which is still has multiple links and also does the enhanced part of it. And we also expect this multi-link operation to be used in mesh backhaul because I think that's where the throughput improvement as well as the latency reduction may help in the communication between the AP and the extender. So probably in some later WBA conference, we'd be able to present more of this stuff as it comes. Thank you.
Oh, perfect. Yeah, let me give you just 1 minute, Necati, to invite Arunav as well. He's the senior manager at Alethea and has been doing a bulk of this testing. Yes, we'll just have a few questions. I have a few, but let's jump here immediately to Necati.
Thanks for sharing the data over here. Now, looking at the EMLSR case, congesting both bands with the 80% over there does not sound really realistic. And then it is actually somehow pushing the wrong button in a way that basically EMLSR, the point over here, one of the bands is going to be congested so that device over there can make a decision, say that, look, 6 gigahertz is congested, maybe I just move to 5 gigahertz or vice versa, so that you just leverage which band is available. Now, if you congest both bands over there with 80% over there, you don't leave any escape. And that is not the realistic scenario. I think the data over there does not speak the truth in the way that you would otherwise demonstrate. If you just congested one link, you would see significant improvement on the performance and as well as the latency. And I would be curious, to see the one link congested data as well, so that it would help us to understand it better.
Well, for sure, actually, I have the data because originally I had a 10-minute slot, so I had to just remove some slides, and the slides that I removed are the one where there was interference in one link because of that. But I will surely share with you. And in case of interference on one link, I completely agree that EMLSR is going to actually perform almost at the same level as MLMR STR. I would share the results with you maybe after the lunch. And on the part that this is not 5 gigahertz and 6 gigahertz, why I selected this and not a 2.4 and 5 is because of the asymmetry of the bandwidths mainly. It's kind of complicated with TCP to actually test with asymmetric links. So I understand that I have simplified the test case in this case, but I hope you would understand the direction in which it is going.
Yeah. No, maybe I would complement one of the values I see. It's all the discussion about new features when a new generation comes. And clearly, you guys are able to go and just baseline these with some early data. Because if we go to the field, I agree with Necati, but we don't have a way to go to the field and test it. So why check? In fact, for our trials, is something that I believe will be very, very useful. So maybe, Arunav, given your testing experience, I would say that MLO is proving successful, especially for interference-driven environments. Do you think, with your findings and the testing you have been doing, we are close to standardize or to recommend MLO to some deployment, some device types? What's your opinion on that?
Sure. Nowadays in the market, it's already there. Okay. So we have with all the testing that our team has done and at our labs, we obviously see that even with Rama's presentation, we've seen that there is, if not very much significant, there is a difference when it comes to MLO clients and non-MLO clients. So I would feel that, yes, as Rama said, EMLSR clients would be more dominant in the market, but gradually with the increase in technology and the reduction in cost, I'm sure MLMR clients will also flood the market. That way, it'll be definitely of good help.
I would just like to add, from the traditional band steering, we have really moved ahead. So there is no longer going to be band steering. Okay, so I think that's a big deal. Post that, I really think that it's now 2 years since Wi-Fi 7 is introduced. I think MLO is in a better position now than when compared to OFDMA at the same time. It took a lot more time for the OFDMA to mature. I think MLO is fast getting there.
And just to pick up on that, I think, of course, with Wi-Fi 6, we had this OFDMA, and I wanted just to double click on that. So from your experience in the beginning, it was either OFDMA or MLO or both combined. So are we in the position now to say that probably MLO is the winning feature when it comes to mitigating, band steering, interference, or do you believe there will still be a role?
It will still be a mixture, for sure. It would be a mixture, and I think the OFDMA algorithms on the AP are fast maturing. So they are able to better guess the traffic flow and actually optimize the allocation. And we do see an improvement with respect to OFDMA as well. So probably because now it's OFDMA is one generation older, so OFDMA plus MLO is probably a good combination.
Very interesting. Let me just check if there's any questions from the audience on Wi-Fi 7 testing, anything. Okay, so maybe I would like also to complement and ask you, how soon, if I'm planning the development of my products, either there is release 2 of Wi-Fi 7 coming, then we'll have Wi-Fi 8, how soon should I just start this type of testing, right? You mentioned device availability, you have the tools to inject traffic on the network. Is there a timeline in terms of the stage a vendor should engage and do testing?
Testing with respect to Wi-Fi?
Yeah, with performance, and I'm on my product development cycle, right? So I have an initial prototype. You guys are able just to provide some data on the performance of, because you mentioned the FDMA is maturing, but people need to know whether their solutions, their algorithms, their code is mature enough. So any recommendations there, or?
Any recommendations on the timeline, you say, or the
timeline for people to engage with you and do this type of testing, like we do in the WBA. You saw that Wi-Fi 8 has a timeline for trials, and you guys are fundamental because we have some of the tools to help us getting data.
Okay, for the MLO part, we are ready. Actually, we have a MLO scale solution already that supports 64 MLO clients. So for the MLO part, we are ready today. And for the OFDMA part, I would give it a quarter before.
Quarter?
Well, yeah. Okay. And before we launch a solution that actually can test OFDMA properly.
That will be a nice combo. Okay, so
we have a solution here, Bruno. So anyone who's interested to see how Wi-Fi 7 is being tested, please do visit our booth. We are just here. Okay, so we have the solution in front of you, and we can show you live testing if needed. Okay, thank you.
Absolutely. Thank you so much.
Thank you for the time.